The great physicist Julius Robert Oppenheimer recalled his thoughts while witnessing the first atomic bomb explosion in human history during a televised program aired in 1965. People are often remembered only for their greatest success or failure. For Oppenheimer, this meant being the mastermind behind the team that, for the first time in history, harnessed the energy of the atom to create a bomb. Some viewed it as the key to ending World War II and saving millions of lives instantly, while others saw it as the cause of the mass killing of hundreds of thousands within seconds. In short, he was known as the father of the atomic bomb. But people are never solely defined by their greatest triumphs or failures. Oppenheimer was not just a brilliant physicist. He was also a lover of poetry, possessing extraordinary charisma and intelligence that captivated everyone he met. He spoke or understood 7 different languages, including Latin and Sanskrit. Horseback riding was one of his greatest passions, and his penchant for romantic entanglements often wreaked havoc in his personal life. These traits, combined with his contradictions and mysticism, created the story of Oppenheimer, a story filled with complexity and depth. This is that story. Robert Oppenheimer was born on April 22, 1904, in New York, to a wealthy textile merchant father and an artist mother. His parents were originally Jewish but did not practice Judaism. They lived in a luxurious mansion adorned with paintings by giants like Pablo Picasso and Van Gogh. Robert's brother, Frank, also became a physicist and later founded the San Francisco Exploratorium Museum, which inspired many science museums worldwide. As a child, Oppenheimer was peculiar and frequently ill, spending much of his time at home. To amuse him, his father once gifted him a mineral kit, sparking his lifelong interest in geology, a step that marked the beginning of his journey into science. Ironically, Oppenheimer attended a school that focused on ethical humanism, teaching students how to live more morally upright lives. Here, he developed a love for literature and mineralogy while striving to become an ethical young man. In his final year, he became interested in chemistry. When he graduated in 1921 at age 17, he enrolled at Harvard College. Unfortunately, the following year, he was diagnosed with colitis, which causes inflammation and ulcers in the intestines. To help him recover, his father sent him to the countryside in New Mexico. There, Oppenheimer fell in love with horses and often disappeared for 3 or 4 days at a time, exploring the vast, desolate landscapes of New Mexico. These adventures would later prove invaluable when he needed to choose a location for testing the first atomic bomb. While studying chemistry at Harvard, Oppenheimer was also required to take courses in history, literature, and philosophy, where he excelled. He chose independent research in physics and became fascinated with experimental physics after taking the thermodynamics class with Pierce Bridgman, who would later win the 1946 Nobel Prize in Physics for his work in high-pressure physics. Tick-tock. Oppenheimer graduated in just 3 years with the highest honors, summa cum laude. Afterward, he was accepted to Christ's College at Cambridge, an institution attended by luminaries like Charles Darwin and John Milton. Oppenheimer initially aspired to study under Ernest Rutherford, one of the greatest experimental scientists in history and a Nobel laureate in chemistry. However, Rutherford, unimpressed with Oppenheimer's experimental background, advised him to pursue theoretical physics instead. Nevertheless, Oppenheimer was determined to join Cambridge's Cavendish Laboratory and eventually became a student of J.J. Thomson, who discovered the electron and won the 1906 Nobel Prize in Physics for his work on electrical conduction in gases. At Cambridge, Oppenheimer was deeply unhappy. He struggled in Thomson's lab and felt he was learning nothing. His relationship with his advisor, Patrick Blackett, was fraught with tension. Blackett, known for his strict nature, pushed Oppenheimer to his limits. According to playwright Francis Ferguson, a close friend, Oppenheimer once left a poisoned apple in Blackett's office. Thankfully, the incident was discovered before any harm occurred. Oppenheimer avoided legal punishment thanks to his family's influence, but his behavior marked a troubling period in his life. In 1926, Oppenheimer left England to study theoretical physics at the University of Göttingen under Max Born, a pioneer in quantum mechanics. During his doctorate, Oppenheimer published nearly 15 papers and contributed significantly to quantum mechanics. He co-developed the Born-Oppenheimer approximation, a foundational concept in quantum chemistry. Oppenheimer's brilliance began leaving an indelible mark on the scientific community. However, his intense personality alienated many, sowing seeds of conflict that would persist throughout his life. This marks the beginning of Oppenheimer's journey, a story of unparalleled scientific achievement and deeply human contradictions. The rest of his life, from the Manhattan Project to his post-war struggles, would cement his legacy as one of history's most enigmatic figures. In September 1927, Oppenheimer arrived at Caltech on the west coast of the United States. There he collaborated with Linus Pauling, a chemist whose work on the nature of chemical bonds earned him the 1954 Nobel Prize in Chemistry. Pauling would also win the 1962 Nobel Peace Prize for his activism against nuclear weapons proliferation, making him one of only 5 people to win 2 Nobel Prizes in different fields. Oppenheimer and Pauling formed a strong working relationship, with Oppenheimer gifting Pauling his extensive mineral collection. Together, they made significant strides, with Pauling focusing on chemistry and Oppenheimer tackling the mathematics. However, Oppenheimer's personal life complicated their partnership. He developed feelings for Pauling's wife, Ava Helm Pauling. Once, in Pauling's absence, Oppenheimer visited Ava and asked her to run away with him to Mexico. She declined and informed her husband, leading to a severe rupture in their relationship. Despite their scientific collaboration, Pauling refused to work with Oppenheimer again, even rejecting Oppenheimer's later offer to lead the Manhattan Project's chemistry division. During a visit to Paul Ehrenfest's Institute in the Netherlands, Oppenheimer demonstrated his linguistic genius by learning enough Dutch within 6 weeks to deliver lectures in the language. This ability left a lasting impression on his colleagues, who nicknamed him Oppie. Later, Oppenheimer worked with Wolfgang Pauli at the Swiss Federal Institute of Technology, the alma mater of Albert Einstein. Pauli's critical approach to problem-solving deeply influenced Oppenheimer's methods, shaping his approach to physics and leadership. Returning to the U.S., Oppenheimer accepted a professorship at the University of California, Berkeley. However, his health deteriorated due to tuberculosis. Seeking recovery, he retreated to his brother Frank's ranch in New Mexico, where he rediscovered his love for the desert landscapes he had explored as a young man. He would later call the desert and physics my 2 great loves. Oppenheimer's charisma and intellect made him a magnetic figure at Berkeley, where he trained the next generation of physicists. His students revered him, emulating his speech mannerisms and even his walk. Oppie's hands-on approach to teaching inspired deep loyalty. During this period, Oppenheimer began collaborating with Ernest Lawrence, inventor of the cyclotron, the first circular particle accelerator. Lawrence, who won the 1939 Nobel Prize in Physics, aimed to split the uranium atom, a goal that would lay the foundation for nuclear weapons development. In 1939, Albert Einstein and Leo Szilard sent a letter to President Franklin D. Roosevelt warning that Nazi Germany might be developing an atomic bomb. This spurred Roosevelt to launch the Manhattan Project in 1941, with the goal of developing a bomb before the Axis powers. By 1942, the project had grown, and General Leslie Groves was appointed to lead it. Despite Oppenheimer's lack of a Nobel Prize and rumors of communist affiliations, Groves chose him to head the project's scientific efforts, citing his unparalleled charisma, intellect, and dedication. Oppenheimer immediately began selecting a test site. Drawing on his memories of the New Mexico desert, he chose a location near Santa Fe. This site, Los Alamos, would become the heart of the Manhattan Project. Initially envisioning a small team, Oppenheimer quickly realized the project's scope required thousands. By the time the project reached its peak, over 6,000 people were working at Los Alamos. The team faced a major challenge when the plutonium they received proved unsuitable for a standard bomb design. Oppenheimer shifted focus to an implosion-type bomb, which used explosives to compress plutonium into a critical mass. This bomb, nicknamed Gadget, would be tested in the first-ever atomic explosion, the Trinity test. In parallel, Oppenheimer's team developed the Little Boy bomb, designed to use uranium-235. This bomb would later devastate Hiroshima. A third design, the Fat Man, refined the implosion concept and was used on Nagasaki. On July 16, 1945, at 5:29 a.m., the Gadget was detonated in the New Mexico desert. The explosion released energy equivalent to 24,800 tons of TNT, creating a blinding flash visible from miles. The heat melted sand into radioactive glass, while a mushroom cloud rose 12 kilometers into the sky. As Oppenheimer watched the explosion, a line from the Hindu scripture Bhagavad Gita came to his mind. Now I am to become death, the destroyer of worlds. This moment marked a turning point for Oppenheimer. While some of his colleagues celebrated, he was haunted by the implications of their work. Just weeks after the Trinity test, the U.S. dropped Little Boy on Hiroshima on August 6, 1945, and Fat Man on Nagasaki 3 days later. Together, the bombs killed over 200,000 people. Although the bombings ended World War II, Oppenheimer quickly became disillusioned. He questioned the necessity of using the second bomb and felt deep remorse for the suffering caused. On August 17, he wrote to Secretary of War Henry Stimson, urging a ban on nuclear weapons. Oppenheimer's communist associations in opposition to the hydrogen bomb made him a target during the McCarthy era. In 1954, his security clearance was revoked after a controversial hearing, effectively ending his role in government science. Despite his fall from grace, Oppenheimer continued to lecture and contribute to science. In 1963, President John F. Kennedy posthumously awarded him the Enrico Fermi Award, recognizing his contributions to physics. In 1967, Oppenheimer succumbed to throat cancer at age 62. His ashes were scattered on Street John, island he had loved. Oppenheimer's life is a testament to the dual-edged nature of scientific discovery. His brilliance brought about both extraordinary advancements and unimaginable destruction. His story reminds us of the ethical responsibilities that come with the pursuit of knowledge. As we navigate new scientific frontiers, Oppenheimer's life serves as both a cautionary tale and an inspiration, a reminder that science, like humanity itself, holds the potential for both greatness and tragedy. As much as Oppenheimer became synonymous with the Manhattan Project and the atomic bomb, he spent the latter half of his life grappling with the moral implications of his work. His post-war advocacy against nuclear weapons proliferation and his opposition to the hydrogen bomb project alienated him from both the scientific community and the government he had once served so loyally. This inner conflict exemplified the duality of his character: the scientist devoted to understanding and harnessing the forces of nature, and the humanist torn by the catastrophic consequences of his creation. He once reflected, in some sort of crude sense which no vulgarity, no humor, no overstatement can quite extinguish, the physicists have known sin, and this is a knowledge which they cannot lose. While the atomic bomb defined his public image, Oppenheimer's contributions to theoretical physics remain profound. His early work laid the groundwork for several key concepts in quantum mechanics, atomic physics, and astrophysics. Born-Oppenheimer approximation. Developed during his doctoral studies, this method became a cornerstone of quantum chemistry, allowing the separation of nuclear and electronic motion in molecules. Positron prediction. He theorized the existence of the positron, which was later experimentally confirmed and awarded a Nobel Prize to Carl Anderson. Black hole theory. Collaborating with Hartland Snyder, Oppenheimer predicted the collapse of massive stars into singularities, now known as black holes. Nuclear reactions in stars. He contributed to the understanding of stellar processes and their role in the synthesis of heavier elements. Despite these significant achievements, Oppenheimer's career was overshadowed by the moral weight of the bomb, a creation that he would never truly reconcile with. The 1954 security hearings marked a devastating chapter in Oppenheimer's life. Stripped of his security clearance and labeled a possible Soviet sympathizer, he became a pariah in the eyes of the U.S. government. Yet his defenders included some of the brightest minds of his time, from Albert Einstein to Enrico Fermi. Edward Teller's testimony during the hearing, suggesting that Oppenheimer was unfit for governmental responsibilities, further isolated him. Teller's words enraged the scientific community, with many seeing it as a betrayal of a man who had shaped modern physics. Oppenheimer himself remained stoic in the face of adversity. The hearings took an undeniable toll on his spirit. He later reflected, "In the Council's work, in the day's decisions, and in our lives, there is no simple right answer. But our work must be done in truth, and it must be done in hope." The advent of the Cold War brought with it the arms race, and Oppenheimer found himself at odds with the prevailing winds of policy. His opposition to the development of the hydrogen bomb, a weapon far more destructive than the atomic bomb, became a point of contention with figures like Edward Teller and government officials. For Oppenheimer, The hydrogen bomb represented an unacceptable escalation of warfare. His refusal to support its development further fueled accusations of disloyalty. Yet his stance was rooted in a vision for a future where science served humanity rather than its destruction. After losing his security clearance, Oppenheimer retreated from the spotlight but continued to contribute to the scientific and philosophical discourse. His lectures drew large audiences, and his thoughts on the intersection of science and ethics inspired a new generation of thinkers. In 1963, President John F. Kennedy's administration awarded him the Enrico Fermi Award, a gesture of reconciliation. Though Edward Teller nominated him for the honor, Oppenheimer remained distant, never fully repairing the relationships fractured during his fall from grace. Diagnosed with throat cancer in 1965, Oppenheimer faced his final battle with dignity. He passed away on February 18, 1967, at the age of 62. His ashes were scattered at St. John in the Virgin Islands, a place he had cherished. Today, Oppenheimer's story remains a profound narrative of genius, ambition, and the ethical dilemmas that come with scientific discovery. His life continues to inspire debates about the responsibility of scientists in the modern world. Oppenheimer's legacy offers a complex tapestry of triumphs and tragedies. As we navigate an era of rapid technological and scientific advancements, his life serves as a stark reminder of the weight of ethical responsibility in scientific pursuits. Balancing progress with ethics, Oppenheimer's story underscores the need for thoughtful consideration of the consequences of innovation. Scientific discovery should aim to uplift humanity, not endanger it. The duality of genius, Oppenheimer was a brilliant yet flawed figure. His life exemplifies how great intellect can coexist with personal struggles, highlighting the humanity behind the history-making achievements. Science as a double-edged sword. The atomic bomb transformed warfare, but also raised questions about the role of science in society. Oppenheimer's life reminds us that with great power comes great responsibility. Oppenheimer once said, "The most beautiful experience we can have is the mysterious. It is the fundamental emotion that stands at the cradle of true art and true science." His life was a testament to this philosophy, a relentless pursuit of knowledge tempered by a deep awareness of its impact on the world. As we remember his contributions, let us also heed the lessons of his life, to wield the power of science with wisdom, humility, and a commitment to the greater good.